Hey, year 10s, how's it going, guys? Nice to see you all. Okay, guys, so I'm going to be really honest. We're not doing GCSE today. If I'm going to do it, I just may as well do it properly. So this really is, in fact, all of today is A-level. But it's just, yeah, do you know what? If you don't want to be here for this, once I've done the register, Isabel and Rue have just got here, which is great. Doing really well on the register. Missing Harris, Nick, Yura, and Ruby. Is Yura watching? Does anyone know? Harris, yo. Just missing Nick, Yura, and Ruby. That's it. Has anyone heard from Yura? Yura, Nick, Ruby. Yes, she's watching. Amazing. Okay, so I've got Yura. Just missing Ruby and Nick now. That's it. And as I said, today is an A-level lesson. I want you guys to be able to name all the organic compounds. I just want you to be ahead of the game. And since we've already finished the year 10 content, I may as well do some of the bits that are far more fun and games, and then I can just really push you guys. By the end of organics, I'm just going to have you guys being able to name all the families. I'm just going to give you all 10. I just think I may as well. Hi, Ruby. Nice to see ya. Got boo-boo. Just Nick missing now. Somebody message Nick. Where are you, Nick? Come on, lad. Come on. Oh, no, I've gone Yorkshire. Has anyone seen Nick? Nick, hello. Where are you? Okay, I guess I'll mark Nick as absent. We're in 2 minutes. I'm a bit disappointed, to be fair, because last time we were nearly done after like 20 seconds. Like, I'm not gonna lie, you know? I'm getting big expectations. Yeah, I'm just gonna teach you to guys. I think what I'm gonna do is I'm just gonna do naming for the next week and a half, so that you guys. There's Nick. Hi, Nick. We're all here. Whoop, whoop. So yes, today is a 100% A-level lesson. I just think it would be fun for you guys to be able to name at that level. It'll make all the naming stuff you do at GCSE a doddle. Okay, right, let's share screen. Share screen. So I have made the lesson activity. Let's get rid of my face. Don't want my face. Get rid of that ugly mug. Right, okay, so 10D, hello, right, go all the way down to organic. There we go. Why is there no title? There was definitely, oh, there we go, the title's taking a while to load. Okay, add new page. Okay, so, as I said, guys, I know how amazing you guys have been for me, and I genuinely think you're going to love the organic side. It is the best part of the whole of chemistry. And you guys are going to love all this stuff. So it's worthwhile me just going the extra mile. And don't get me wrong, when you get round to the GCSE stuff, we will only focus on the bits you need. But it's nice to be able to do the little bits extra that I'd never usually get to do, because usually I'm pressed for time to finish. And now I'm not, which is dead nice. So today, this is Organics lesson 3. And this is naming part 2, really. Naming part 2. And what we're doing is we are having a particular focus now. Yeah, so we are now focusing on naming branched alkenes and alkanes. My learning objectives. Yeah, I'll actually put branched up there and underline it. So I need you guys to be able or understand naming branches, naming branched alkenes and alkanes, alkenes. Next, what I need you guys to be able to is I need you guys to be able to read skeletal formulae. Now, guys, this skeletal, guys, I'm not going to lie. This is totally A-level. You do not do this. Here is A-level. In fact, it's all A-level. The whole lot of it is A-level. Yeah, this formulae does not appear at GCSE, but I'm doing it anyway just because it's fun. Yeah, And I'm going to add a learning objective now because I need you guys to be able to name cyclics. Name cyclic compounds. Yes. Okay. So I've got 3 learning objectives today. So I'm actually going to do them out of order. I should always in reality, I don't number these. I don't put like 1 to 3. I just put, I need to hit all of these 3, and then I kind of build these things in my head. And the first thing I'm going to do is I'm going to do formulae. So you can put a little subtitle, please, guys, of organic formulae. Okay, so in organics, there are actually several types of formulae. There's different types of formulae in all of chemistry, and you guys have already seen a load of these, but it's nice just to show you that organics is genuinely special. And yes, it is kind of like learning how to read. It is a language. So the types of formulae are, the first one is, of course, number 1, molecular. This is GCSE. The actual number of atoms of each element in a compound. You know this one. Molecular formulae, e.g. Let's do an example. Let's do the example in green. So the example being C4H10. On the chat, please. Name it. Yeah, now this is the actual number of atoms of each element in a compound. Let's write that down as a reminder. Yeah, actual number of atoms of each element in a compound. So we know, if somebody said to me, what does this formulae tell me about this? I love this. Butane, love it. Rue said I can't count. Oh, hang on. What did you do? What did Rue do first? Rue, what did you do? Ruby put butene. No, not butene. Counting ability 100. Okay. Yeah, no, butane, Ruby. The reason being is it's CnH2n plus 2, Ruby. I'll make that clearer. H2n plus 2. Now remember, that plus 2 is because when you draw it out, you see the 2 extras at the end. Oh, typo. Fair enough. Oh, I meant een. I love the fact that you wrote butene, then you put, oh, I meant een, when you would actually put een, but you actually meant ain. Sorry, I shouldn't laugh, but that's brilliant. Number 2, which is GCSE. You guys know this one too. Number 2 is the empirical formulae. Empirical form. Yeah, this is the simplest ratio, the simplest whole number ratio. I know, right, Ruby? This is the simplest whole number ratio of atoms of each element in a compound. So we can do C2H5 is what that one there would translate to if it was empirical. Let's put on that little note, the simplest whole number. I don't know what accent I'm doing, but I'm doing one. Simplest whole number ratio. Whole number ratio of atoms of each element in a compound. Notice how it ends in the same way. Of atoms of each element in a compound. The element in compound. So these two are GCSE all day long. Yeah, they love those 2 definitions. They love. Then we continue this and go to number 3. We then pick up try an Aussie. Oh no, Isabel, I can't do an Aussie. I can't do it. I need to work on my accents. I need to add a few more to my repertoire, definitely. I did a London the other day, and I don't even know how I did it. I couldn't do it again. It's really weird. It just came out. It was really bizarre. The next one is displayed formula. This is also GCSE. Displayed formulae. Yeah, and displayed, of course. I'm going to switch to green again. I'm loving my examples being in green. You know, love this. Where the definition of this one is a diagram showing all bonds in a compound. Yeah, so here is the displayed showing all the bonds. It literally is displaying itself. Yeah, there we go. So this is displayed. A pictorial representation showing all bonds in the compound. A diagram I love the fact I use the word pictorial. A diagram showing, and this is the key thing here now, folks, all, capitalize, underline, all bonds in compound. Yeah, this is the one that everyone loves. They learn to love it. Yeah. The next one, which is actually GCSE, but not really. These now pretty much leave. This is now A level. The next two are A level. These three here are GCSE. And we now leave GCSE behind, and we get the hardest one of all of them, which is a structural formulae. This is a written, by the way, do you notice I've stuck with C4H10 the entire time? Yeah, I'm going to do this in green. Everything's linked together. CH3, that's this guy. Yeah, CH2, that's this guy. CH2, that's this guy. And CH3, that's this guy. Yeah, this is a written formula showing structure. You need to do it in red. A written formulae showing arrangement of atoms, showing arrangement of atoms. So you can always translate, because of these two all show structure, these two here, you can always, if you can't, then you've not understood it. You can move between these guys no matter what happens. You can always go from here to here or from here to here. I didn't like the reversible sign. Yeah, you can move between those two. Now, the last one for A level, these latter two, of course, are all A level. The last one is skeletal. Now, I'm going to teach this to you, but I need you guys to be able to filter. But I know you can. Yeah, and also in reality, I realize that you don't really need to filter because you're never going to see this again except from me. So in reality, the filtering will come from just never seeing this again, and I'm okay with that. And here's the skeletal formula of butane. Ah, no. That's the skeletal. I'll make that better. The skeletal version of butane is that. Now, what this shows, this is the skeleton. Yeah, this is no, it needs to be in red. A line drawing showing only carbon skeleton and other atoms and anyone not carbon or anyone other than carbon and hydrogen, which is a nightmare, and functional groups. And to be fair, that's actually I've never actually seen that as a definition on an exam. They've never actually done it. But just to show you how this translates, it shows the carbon skeleton because, and this is the nota bene that goes with this. Yeah, nota bene. At each kink, yes, this is a kinky formula. Yeah, at each kink / joint is a carbon. Yeah, so what that means is I could translate this out. I'm going to then redraw it and then translate it out. Yeah, there's a carbon here, carbon here, carbon here, and a carbon here. And now I know that everybody else now everything needs to add up to 4. So I can now, if I want to, populate it with hydrogens like that. There you go. There's butane. And yes, it has this kink. The reason why by the way, the shape of these molecules is actually kinky. It's actually kinked. But it's nice just to show you how that translates. Yeah, if you'd like, what you can do is you can draw that and then overlay it with a different color. Yeah, each kink and joint goes a carbon. Yeah, and then you can populate it with hydrogens if you wish. Yeah, that's what that translates to. We're going to see this today anyway. So that's all the types of formulae that you pick up. These latter two are A level. I'll do these in purple. Yeah, these latter two are A level. So I'm just going to give you a couple of questions regarding this. Kinky formulae. Yeah, very kinky. Very, very kinky. Yeah, right. So zoom in and let's go for examples of these, e.g. So let's now do, let's do this one. So on the classroom, guys, number 1, can you name my diagram? Name my compound. Number 2, what about this one? Yeah, what about that one? Name that one. Number 3, can you now name that one? And then number 4, can you name for me? Got to be careful here. By the way, they can actually do this. They can actually do that. Yeah, I know. Crazy or what? Ah, look at that. Isn't that clever? So I've got the first 4 people are spot on the first one. So number 1 is propane. Well done, guys. This one is propane because I have a carbon, carbon, carbon. The next one, number 2, well done for number 2. Only 2 people on number 2. Yeah, number 2, of course, is propene. Well done for that one. There's propene. Then we have number 3, of course, which is butane. Yeah, you guys are killing this. You get it. You get the point. And the last one, 1, 2, 3, 4, 5, 6, hexane. I'm going to give you one more. Yeah, let's now make it harder. Maybe I'll give you a couple more. Nah, I'm enjoying the game. Number 5, how about this one? How about that one? And then how about number 6? That one. That's harder. Because you've got to remember, guys, you've got to put something in here, remember. I'm going to make this easier to read for that one. There we go. How about those 2? So very similar. No, nobody's got any of them yet. None. No, you're all wrong. Remember, you need a number. You need a number. Ben, you're wrong. Everyone's wrong. They're both butenes. But, Ashley, are you talking about number 5 or 6, Ashley? Remember, numbers. Wait, I forgot the dash. You did. Ruby, well done. So number 5, the carbon-carbon double bond is between carbons 2 and 3. This is butene. And then this one, the carbon-carbon double bond is between carbons 1 and 2. So this is butene. Does everyone get that? I thought they were the same, just different viewpoints. No, Ben, they're not. They're not the same. Definitely not. Yeah, they are different. GCSE, if you want GCSE, butene. No. Yeah, you can name those just as butene at GCSE, but at A level, and I'd like to think that you guys can work at an A level. I know you can, in fact. Ben, I told you to watch the other vid. Yeah, Ben didn't watch it, did he? No, of course he didn't. I shouldn't say that. Sorry, Ben. I know that you would do it. Please make sure you get to watch it. It's important. Okay, so it's nice for you guys to realize skeletal's actually nice and easy. I suddenly remembered year 9 content. Mr. Duncan, Toby can't join. His MacBook has a problem. Oh no. When should we include the dash? When should you include the dash? The dashes separate numbers and letters. Yeah. So other naming rules. Yeah, a dash, 1 dash. Yeah, the dashes separate numbers and letters. So this is another nota bene. Separate numbers and letters. See what I did? Use a dash. Yeah, to separate 2 numbers. To separate numbers, you use a comma. I think that's amazing. Yeah, to separate numbers, comma. You'll see that shortly. When should we include numbers in a dash? Just always put the numbers in. If you can move something, you include the numbers. Just you'll get used to that. The answer is whenever you can. If you ever have a position of any functional group, any piece that's not the stem, just include the number. Yeah. Right, so now that you guys can all read skeletal, what I'm now going to do is naming the cyclics. So, doing this in a really funny order. So, okay, so everyone put cyclic compounds. Okay, so the word cyclic literally means in a circle. That's what it means. Yeah. So for example, e.g., if I said, e.g., I'm going to ask you guys to name this guy for me. Everyone name this one for me on the chat. So Toby's MacBook has crashed and he can't get on. Lol. Everyone name that guy, please. And then name this one. Thank you so much, Kieran, Ben, Con are on it. Well done. Here is propane. So I went Italian there. Followed by cyclo. Yes, cyclopropane. Yeah. Yeah, it's a prop because it's 3 carbons. It's an ane because they're all single bonds between the carbons. And it's cyclo because it's in a circle. Whoop, whoop. Cyclopropane. Yeah, I like it. Let's have a go at another one. So let's now go to EG2. Can everyone now name me this guy? Name me that guy. I think you know where I'm going with this one. And then name me this guy. Giving you displayed all the time, by the way. I'm going to switch out of that in a minute. Going to switch it up. I like it. Ruby, you've done it again. Stop it with your E's, will you? Jeez. Watch out for that, Rubes. Well done. We've got butane, followed by cyclobutane. Okay, are you ready for your next one? Oops, yes, Ruby. EG3. Okay. Name me that one, please. And then name me that one. Switched into skeletal. You're never allowed to use this at GCSE, by the way. Ever. Ever. This will be the only time, the only lesson you'll see this until year 12. Nope, it's not ethene. That's really interesting that Ben and Ruby both got that wrong. Remember, it requires a process. You never jump in organics, ever. You have to actually think about this. Every joint, yeah, thank you. Ben's like, whoa. Every joint has a carbon. Rue's on the next one. Well done. Oh my God. It's not that hard, Ben. It really isn't. What did I just do? Oh, Ruby's on it now. Ben, my eyes, lol. And then carbon. So this one here, of course, is just propene. Oops. Propene. Yeah, and this is cyclopropene. There you go, cyclopropene. Amazing. You ready for your next one? In a cyclo. Oh, whoa, lost it. There we go. I thought the lines were the carbons. The lines are the carbons. But no, yes, but that's a double bond. That's a double bond. It doesn't mean there's another carbon in there. You get the number for the double bond. The smaller one. You always count across a double bond. Cyclopropanene if you really want. Like where the double bond starts. Yes, whenever you do, okay, yeah, fine. I'll give you EG4. EG4. So we can now do this. I've started, so I'll finish. There we go. And if you were going to number this, you always number across a double bond. So you'd always start with him to him, or you can go in the other direction if you prefer. Doesn't make any difference in this case. So what's the name of this guy? Not that you need the number for this particular one. What's the name on the chat, please? Name on the chat, please. Let's turn that to skeletal. Winner. Look at that. Da, ba, da, da, da. Cyclobutane. Thank you, Roo. These two are the same, by the way. Same. Same. Just one's displayed and one is skeletal. Cyclobutanene. Love it. Cyclobutanene. Love it. It's great. Cyclobutanene. It's the same thing. Loving it. Oh, I forgot the dash. Oops. Okay. So I think everyone's okay with cyclos. Think everyone is okay with skeletal. Let's move on. We're making good progress today. Right. Next one is title branching. Next one is branching. So far we've been talking about what are called straight chain isomers. So okay. This goes into isomerism today, which is part of GCSE. So C4H10. Now, there's actually turns out to be two versions of this guy. You have got the straight chain one. You have the straight chain. Everyone name it, please, on the chat. I know you're thinking I'm being repetitive, but that's a good thing. We're continuing to reinforce good knowledge. Yeah, naming is tricky. It's a language. If you're going to learn any language, you learn by repetition. Thank you, Rue, first on the chat. Outstanding. Yeah, I'm hoping to see Ruby here giving me the right answer. Picking on you there, Rubes. Thank you very much, guys. But there's another one. There's this guy. Right. Now, this guy now has what is called a branch. This now has a branch. Remember the rules of naming. Rule number 1, find the longest chain. Yeah? And the longest chain here is 3. Can't get any longer, because in order for me to join the next one, can't do that. Can't go, if I go to the other one, I could go this way if I like, but then I can't do that. They don't join together. Yeah, the longest chain I can make is 3. Doesn't matter which chain I choose, it will be the same. Yeah, 3 in a row. What that means is, in the red, this is based on the compound propane. This is prop because it's 3 carbons. And each of these are carbon-carbon single bonds. So it is based on an ane. This is propane. But now it has a branch. And this is called, now the branch contains 1 carbon, which means it has the word meth in it. Now, how do you say branch in chemistry? You say branch with il. Yeah, the letters YL literally mean branch. So this is a methyl branch. So the name of this guy now becomes methyl propane. This now becomes methyl, and yes, the branch goes first in the name. Yeah, oh, look at Ashley. She's absolutely correct. It is 2-methyl propane. Well done, Ashley. Yeah, because it's on carbon number 2 along the longest chain. 2-methyl, Ashley's on it. By the way, I did this with the other class, so Ashley's a little bit ahead because she watched both lessons. She did 2 hours of chemistry yesterday. Can you believe it? Methyl orange! Yes! Methyl orange, guess what it has? It's got a methyl branch. You can start drawing it. Do you want to see it? Do you want to see it? Ooh, ooh. Ooh, I like it. I like it. Methyl orange. Let's find the branch. Let's find the branch, folks. Hang on. Methyl orange molecule. Molecule. Have a look. Images. Where is it? There it is. So it actually turns out that it's actually got 2 methyl branches. Oh, I can't zoom in. There we go. It actually has 2 methyl branches. It should actually be called dimethyl orange, but they don't because, well, it doesn't flow very well. There's like methyl propane, fancy names, then there's orange. I know, right? Well, look how mad that guy is. By the way, this is beyond A level to name this. I can't even name this, guys. That's how hard that molecule is. I can tell you all the individual pieces. Yeah. So this is a tertiary amine with a that's an NN dimethyl. This is a benzene ring. This is hang on a minute. It's an azo linkage. That's an azo di linkage, which is why the methyl orange has a color. Yeah, it's an azo di linkage. Yeah. This here is sulfonate, sodium benzene sulfonate. It's a horrible and hence why it's called methyl orange. Yeah, otherwise known as otherwise known as Bob. Yeah, common name Bob. It's not really. I'm just making that up. Don't tell anyone. Yeah. Anyway, so 2-methyl propane. Amazing. Are we ready for the next one? Okay, this is where Ashley's going to be like, oh, there's more to this. It never ends, Ashley. It never ends. So we can go for the next guy. What about this one? What about this guy? Now, this guy rules. Step number 1, find your longest chain. 3. Now it tells entire internet. So this is based on propane. The longest chain is a prop. They are all single bonds, so it is an ane. But now I have 2 branches. How do I say 2 branches? I say dimethyl. Yeah, and di in chemistry means 2. Yeah, oh, look at Ashley. Kieran, so close, but not quite. But Ashley's in it. Well done, Ashley. Yeah. So this becomes final answer, and these branches are on carbon number 2. So this is 2. To separate numbers, you put a comma, and you have to do 2 numbers for the di. If you have a tri, you have 3 numbers. So 2,2 dimethyl propane. Sorry, I keep dropping into Italian. I can't help it. I'm sorry. I don't know where it's even coming from. No one knows. Nobody knows how to do it. It comes from Italy. I don't know. Next, are you ready for the next one? What about this one? What about this one? And notice that I'm giving you displayed all the time, by the way. How about this one? Right, guys, on the chat, please. Have a go. Go on, have a go. Have a go. Have a go. Have a go. Come on, guys. Come on. Have a go. Sorry, lost my marbles. Come on. Come on. Everyone's gone quiet. I've got 15 people watching. Everyone's gone quiet. Come on. Come on. 2,3 dimethyl butane. Oh, look at it. Well done. Kieran, you've just gone methyl. What? Come on, Kieran. Look at what Rue's done. Make the correction. Ben, good effort, Ben. But it's not 2,2. You've got to count from one direction, and the branches are on carbons number 2 and carbon number 3. So this becomes 2,3 dimethyl butane. Butane. There we go. 2,3 dimethyl butane. Next, you ready for the next one? How about this one? See if you guys can do that one. How about that bad boy? Have a go on the chat, please. That's what that would actually look like in skeletal. Flipped over. That's what the skeletal would look like. 3-ethyl pentane. Well done, Kieran. Well done. Like to have more people on the chat, please. Same people are contributing. Please correct. 1, 2, 3, 4, 5. It's a pent. Single, 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 single. It's an ane. Pent is 5. Ane is single bonds. Branch is, well, wait. And that has 2 carbons in it. And we know that 2 carbons is eth. How do you say branch in chemistry? 3-ethyl pentane. And we're done. Why isn't there another number? Because the ethyl is just on number 3. Where's the other thing? Remember, find your longest chain. Your longest chain is there. Only one branch. If there's only one branch, one number. I got it. Cool. You ready for the next one? How about this bad one? How about this one? How about this one? How about that? How cool is organics? What's the name of this guy? This is I'm pushing you guys hard here, folks. Pushing you hard. Yeah, pushing you hard here, folks. Come on. Don't let me down. Don't let me down. Don't let me down. 1-methyl cyclopropane. Kieran's on it. Well done, Kieran. Well done, Rue. Anybody else? So, longest chain. All singles. Well done, Con. What they both said. Conical flask. I know, right? So this is, and there's the branch. So this is based on cyclopropane. Cyclopropane. And it has a 1-methyl on it. 1-methyl cyclopropane. Yeah, what they said. Too long to type. Nah. Are you ready for your next one? What about that one? It's such a good game. Just to let you know, yeah, you always want to make the number as low as possible. People often say, where do I now start counting? Yeah, and the answer is you'd always put your carbon number 1 at the joint. It would be there. Yeah, and you'd always then count across the double. Yeah, you'd never go the other way. Yeah, you'd always do it like that. There we go. I'll give you a bit of help. A kite. Yes, it's a kite. 1-methyl cyclobutane. Nailed it. Shan, good effort. You'd always make that because you could put the 1 on either. Now, students have done this now, by the way. Students have then done that. Yeah. Well, they've switched the numbers around. They put the 1 there and the 2 there. Let me explain to you why it's different. This becomes 1-methyl cyclobutane. Yeah, we've got 2 1s if we put the 1 there. But if we switch them around, we would get 2-methyl cyclobutane, and you'd always choose the one with the lower numbers. That's all. I know, right? How do you guys type so fast? It's good, isn't it? It's a fun game. Right. Do you want a couple more? Or are you done? What do you want? Name it. Name it. Now that one is important. Have a go. Ooh, fine. Let's just make it more fun. Try that one for size. Look at that. Go for those three. Cyclopentane, outstanding. Roshan, Con, Ashley, amazing. Well done. Cyclopentane. Totally on it. Well done. Superb. Next. 2-methylpropanone. Oh, you guys are good. I love this. 2-methylpropanone. I like it. You're doing this very fast. The last one. This one I'm really pushing you. Really pushing you. Watch out, Rue. It's not an ane. Oh, yeah, it's not an ane, guys. It's an ene. Be careful. Con. It's not an ane. It's not an ane. Watch out. 3,4,5-trimethylheptane. Kieran is on. Kieran, I'm impressed, young man. Well done. It is based on hept. It is all single bonds. It is an ane. And I have a methyl, methyl, methyl. I have a trimethyl. And my numbers are 3, 4, 5. Trimethyl. And that brings us to the end of our lesson, folks. It wouldn't send quick enough. I'm literally out of breath typing. Ah! Oh, amazing. Right, let's go back to this. Guys, that brings me to the end of my lesson. I'll post your homework. That was fun. I'm glad you enjoyed it. That was loads of fun for me to do as well. I always love organics is my favorite bit. It's amazing. When you get good at it, it's so good. Guys, I will set you the homework. It's already made. Do you want to see it? Do you want to see your homework? Just to show you what you guys are up against. And I don't want you to rush this. Take your time. Yeah, I'm just going to quickly show you your homework. Show you that I've already made this. Hang on, there we go. Right, this is what I've made you guys. Share screen. Am I the only one who's rewatching to make notes? Yes, that's fine. Here's what I've made you guys. Yeah, so you've got all of these guys to name. You're going to have a barrel of laughs. You're going to love this. Enjoy loads of stuff. same. Oh, that was a lot of fun. Really enjoyed it. Guys, I'm going to love you and leave you. Have a nice rest of your day. Enjoy your homework. And I'll see you soon. See you later, guys. Someone.